This is Chapter 17, Example 2, and what we have here is a circuit adds two numbers. If the sum of those two numbers, which we'll call A and B, generate a carry, then the circuit outputs A, otherwise the circuit outputs the sum of A plus B. First step in the design process is to draw the top level black box diagram. RES for result, and make sure that's okay. Yes, that looks good. Now the next step in this problem is to take an inventory of the devices we'll need in this thing. See that it's doing a summation. We only know one way to do a summation, and that's with a ripple carry adder, so we'll toss that down. The circuit, we can see it is making a choice, so it's either outputting A or the sum of A plus B. So that means it's outputting one of two things. It's making a selection. It necessarily needs a mux. Put at mux is going to be the output of the final circuit. So we're getting there. I think that's all we need. If we need something else, we can add it. We can set this ripple carry adder up to make it happy. Connecting the input to that's what's being added. And the issue here is we're going to read backwards on this thing. This circuit's going to output one of two things. It's either going to output A or the sum of A plus B. So those are the two inputs, this mux. One is going to be A, and the other one is going to be the sum of A plus B. And these are both 8-bit values. Okay, we're getting there. This mux here needs some way of controlling it, and so what's going to control this, if we read back on the problem, it's going to be the carryout. Now the carryout is just a 1-bit signal. I'm just going to connect it there. I know that's going to make the decision for me. I'm almost done on this thing. I need to put numbers on this circuit. Now usually the way I do this is just to take a guess on this one and then go check it. So there's my guess. And let's check this. Okay, so if there's a carryout, it chooses A plus B, right? It chooses the sum, and that's wrong. If there's a carryout, I want to choose A, so I'm going to go ahead and erase these and put in 1 and a 0. And now it's correct. So here's the A and B in the input, RES in the output. Those matches the black box diagram. I have all inputs connected. I'm using a mux to make a decision. I have the inputs numbered, and I will call this problem almost done because we keep forgetting to say what controls this circuit. So the circuit is making a decision whether to output A or A plus B, and what we want to know is what controls that decision. That means what is connected to this control input on the mux. So for this given problem, we have an internal signal that's connected to the control signal on the mux. So this is internally controlled. And now we are done.